Hello viewers, in our last video we looked at converting improper fractions to mixed numbers, and in the process we employ the method of long division. Now in this video that has to do with rational functions, we are going to extend that concept of using long division. Please, if you did not watch that video on converting improper fractions to mixed numbers, kindly go to my page or to my YouTube channel. It's posted there. It is going to help a lot. So on the screen, you can see an integral, x squared plus 3x minus 1 over x plus 1 dx. What do you do if you are given an integral like this? Well, the first thing you want to do is to look at the degree of the numerator and that of the denominator. If the highest power of the numerator is higher than that of the denominator, then you need to do what is called degree reduction before you can continue. What are we saying in effect? Here, for the variable x, the highest power in the numerator is x squared, while in the denominator, the highest power is x raised to power 1. So in the numerator, we are having a higher degree than that of the denominator. So the first thing we want to do is to reduce the power of the numerator. And how are we going to do that? We're going to do that using long division. Please watch. So here we have brought out that function from the integral sign. Let's work the long division aspect of it outside the integral sign. Now, how do we apply long division? In this case, the divisor, which is the denominator of the fraction, we put it outside the long division sign, and then we are dividing this expression by this expression. So what are we going to do? So if x goes into x squared, you have x. Then you come and multiply this x by this x. So you get x squared, and then you also multiply this x by this plus 1. So that will give you plus 1x. Trying to make it as easy as possible. So what are you going to do here? You will subtract the lower expression from the upper expression. When we subtract this expression from this x squared term will just simply go away, because x squared minus x squared is 0. So we'll be left with what? We'll be left with plus 3x plus minus 1x. And because this is plus minus, this expression becomes minus x. So plus 3x minus x will give us 2x. Do you agree? Then you bring down this minus 1. And then you go again. X goes into 2x. What you get there is plus 2. And you now use this plus 2 to multiply this whole expression. 2 times x will give you 2x. 2 times plus 1, you get a plus 2 there. And you do essentially the same thing. You subtract the lower term from the upper term. But guys, you have to be very, very careful with the signs. So this will go. I was supposed to have used a different marker. Anyway, 2x will go with 2x. And here we have minus 1 plus minus 2. So because this is plus minus, this expression will turn to minus. So we'll now have minus 1 minus 2, which gives us minus 3. So the remainder is minus 3. At this point, we are going to use what is called the remainder theorem. Please watch. So the remainder theorem simply states that f of x equals q of x plus r of x all over d of x. And in this case, the q of x is this expression that you got after the long division, which is x plus 2. Our r of x is minus 3, while our d of x is x plus 1. So we have stated them clearly here. Our q of x is x plus 2, r of x is minus 3. That's the remainder that we got from this long division, and d of x equals x plus 1. So using the remainders theorem, we have broken down this expression into x plus 2 plus, this is our q of x, remember? This is our r of x, which is the remainder that we got from using the long division, and this is the divisor, which is x plus 1. All right, so this expression has now been broken down into x plus 2 minus 3 over x plus 1. So we now reintroduce our integral sign. So the integral of this expression, we can break it down into two integrals, and that will give us integral x plus 2 minus integral 3 over x plus 1. So what have we done here? The same expression under the integral sign. We have broken it down into two different integrals. We now have integral x plus 2 dx minus 3 over integral x plus 1 dx. To reduce this to a form where we can easily integrate it, we have to divide this numerator by 3. That is why we have this 1 over 3 here. So this now reduces to x plus 2 dx minus 1 over 3 integral 1 over x plus 1 dx. So how do we integrate x plus 2 dx? This is simple. To integrate this, we simply say x, this is x raised to power 1. So this will now be x raised to power 1 plus 1, which is 2 all over 2, plus this will now be 2x minus 1 over 3 natural logarithm of x plus 1 plus our constant of integration. So that's it. We've got our answer. This is the integral of this expression here. Did you enjoy this video? If you did, please kindly comment, like, and share the video. You can also follow my page. If you are not doing so, please invite others to follow my page where we share tips like this. Thank you, and bye for now.